Hello and welcome to everybody. In section 9.2, we're going to be kind of focusing on transformations a little bit, but we're going to take a little sidetrack and we're going to talk about what are called matrices. Now, matrices, which is the plural for the word matrix, is one of my favorite mathematical things to work with. It's one that we won't get to go too in depth on, which is unfortunate, but matrices can be used to aid in transforming figures, whether it's rotations, reflections, or whatnot. And so we're going to discuss them, but only in brief within this chapter. All right, and the goal here for this video is that you're going to use matrices to represent the vertices of a polygon, and we're going to use matrix addition in order to translate polygons. All right, well, first question then is, what is a matrix? Well, I have a matrix down here to kind of exemplify what a matrix is, and I'll write the definition for it in a moment. Actually, let's write the definition now. What a matrix is a rectangular arrangement of numbers in rows and columns. And that's exactly what you see right here. You see rows and columns of numbers. Now, a matrix can be used to represent actual quantities. They can be numbers that mean something, or they can just be numbers. That's fine as well. These numbers happen to mean something. You can see that this matrix shows the retail price of various items in the store. And so, just made these up myself, but say this, you're looking for a shirt or a tie or a suit at this particular store in either medium, large, or extra large. I don't know what that means for ties, honestly, but you're looking for that. You see what the price is. Now, why would you care to arrange things in a matrix other than it organizes things a little bit? Well, if you can arrange numbers in matrices, then you can do large-scale operations very quickly. All right. So, for instance, if I was a store owner and I was going to have a 10% sale, I could easily just take this matrix and multiply all of these prices by 90%, because if you save 10%, you'd still pay 90%. I can multiply all those numbers by 90% and very easily see, what is the sell price for each one of those items in the store. Okay. Now, matrices have a lot of applications, especially computer programming and so forth. Lots of things you can do with them. And again, they're used to be able to do a lot of calculations with a lot of numbers very quickly. All right, so that's what a matrix is. Also, one other thing that I'll mention with it right now, something you talk about with matrices quite often are the dimensions of a matrix. You have to consider the dimensions of a matrix. And this one is quite clearly a 3x3 matrix because it's got 3 rows and 3 columns. But I want to make sure that you know, whenever you express the dimensions of a matrix, what the first number represents and what the second number represents. And so the way that works is that the first number represents the number of rows, and the rows are the horizontal values. I'm trying to color coordinate that, so the orange and the orange rows are the horizontal ones. And then the second number is the number of columns. And the columns go vertically, so there you go. All right, well, let's do some geometry with matrices. That's the whole point of this video. What we're going to do first is we're going to learn how you represent polygons or the vertices of polygons using matrices. And the directions simply say to write a matrix to represent the polygon. And you see this pentagon here, PQRST. And what we're going to do is write a matrix that simply says what are the coordinates of each of the points of PQRST. All right, well, how is that going to work out? Well, whenever you're representing a polygon with a matrix, what you're always going to do is have a matrix that has 2 rows, 1 row for x coordinates and 1 row for all the y coordinates, and then you'll have as many columns as you have points on the polygon. So there's 5 points here on the polygon. We're going to have 5 columns. This is going to be a 2x5 matrix, which I'll go ahead and start drawing. Now, these labels don't have to be a part of it, but they will help us tremendously here. Again, the 2 rows are for the x coordinates and the y coordinates, and then the columns are for the points, whoops, we don't have W and X, do we? Are for the points or the vertices of the polygon, PQRST. All right, so what we need to do is figure out what are the coordinates for each of these points. Let's start with P. And you can see that the coordinates of point P are -6, -1. And so we'll write in our matrix -6, -1 in the P column. And then we'll just do the same thing for all the other vertices. X coordinate for each point on top, Y coordinate for each point on the bottom. All right, so now there's the labels for all the other ordered pairs, and we're just going to put those in the matrix. Like so. All right, a very simple thing to do to represent the vertices of a polygon with a matrix. All right, now let's talk a little bit more. The next thing that we're going to work on geometrically is trying to translate polygons using matrices, but I'm going to have to teach you how to add or subtract matrices before we can do that. All right, so I'm telling you here with these different sets of matrices to find the sum or the difference. And there's a very simple principle that I need to communicate with you about adding or subtracting matrices. And that is that it's not always possible to add or subtract two different matrices. The only way that you're able to add or subtract two different matrices is if the dimensions of the two matrices are equal with one another. All right, so for instance, in this first problem, you see that that's a 2-row and 3-column matrix, 2 by 3. Here you see that's a 1-row and 3-column matrix. Those have different dimensions, so it's not possible to add or subtract those matrices. Now there's different rules for multiplying matrices, but for adding and subtracting, it's whether or not they have the same dimensions. All right, whereas if you look at B and C, you do have two matrices with equal dimensions there. Those are both 3 by 2 matrices. And in C, you have a pair of 2 by 2 matrices, so the addition and subtraction are going to be possible. Now, when the addition or subtraction is possible, here's how you do it. You simply add or subtract, depending on what you're doing, the elements. That's what each individual number in a matrix is called as an element. You add or subtract the elements that are in corresponding positions with one another. So for instance, if I want to get the first row, first column element in my sum matrix, I'm going to add the first row, first column with the first row, first column. We're going to do 10 plus -7. And then here we'll have 3 plus 0, and so forth. -7 plus 0, 4 plus 2 goes here, -6 plus 6 goes here, and -5 plus 10 goes there. Now, the resulting matrix from adding or subtracting matrices has the same dimensions. This is also going to be a 3-row and 2-column matrix. Now let's go ahead and simplify. And you can see that we'll get 3, 3, -7, 6, 0, and 5 for the sum. Okay? Do the similar thing then with the subtraction. We're going to subtract the corresponding elements this time. You can see I'm doing 19 minus -10, 5 minus 5, and so forth. And so the result, be careful with your signs always. 19 minus -10 is 29. 5 minus 5 is 0. -8 minus 4 is -12. Make that look more like a 9. And then -8 minus -2 is -6. All right, so that's how you add or subtract matrices. And we're talking about that because in order to translate figures, which is the next thing we're going to do, using matrices, you've got to use matrix addition. Well, yeah, pretty much just addition, not subtraction, in order to do that. All right, so here's the last example that we're going to work on, just to illustrate how you translate a polygon using matrices. It says that the matrix representing quadrilateral WXYZ is this matrix here. So we'll say this column has the coordinates for point W, here's point X, Y, and Z respectively. Find the matrix representing its image after this translation. Now, using your coordinate notation, you can see that the rule for this translation is that we're going to subtract 2 from every X coordinate and add 1 to every Y coordinate. And so that means we're moving 2 left and 1 up in this translation. Then we're going to graph the polygon and its image. All right, well, let's go ahead then and do the translation first, and then we'll do the graphing afterwards. I'm going to copy this matrix below so I can show you how the addition works. Now, the matrix that has all the coordinates for the vertices of the polygon, we can just call that the polygon matrix. And then let's think about this for a moment. We're going to try to add another matrix with this polygon matrix, and the goal is to subtract 2 from every one of our X coordinates, and we're going to add 1 to every one of our Y coordinates. Now keep in mind, in order for it to be possible to add 2 matrices, those matrices have to have the same dimensions. So since this is a 2 by 4 matrix, we've got to have another matrix that's a 2 by 4, and here's simply how that's going to work. We're going to have a 2 by 4 matrix, and since we're wanting to add -2, we'll say, I know it's subtracting 2, but let's say we're adding -2 to every one of the x coordinates, what we're going to do is we're going to make the first row contain all -2's. So when we add the matrices, we'll have -3 plus -2. We'll have -1 plus -2, and so on. And then since we're going to increase each of the y coordinates by 1 in our translation matrix, which is what this is going to be called, we're going to put 1's in all over the second row. So we'll increase each of the y coordinates by 1. So translation matrix again is what that's called. Now the result of adding that pair of 2 by 4 matrices together is that we're going to get a 2 by 4 matrix. And that 2 by 4 matrix is going to be displaying the coordinates of the image of our quadrilateral after the translation. So we'll call that the image matrix. Alright, so -3 plus -2, -1 plus -2, 3 plus -2, and 4 plus -2. Those are going to be the x coordinates for our images. And then we're adding 1 to all of the y coordinates. So 6 plus 1, 0 plus 1, -2 plus 1, and 1 plus 1. Excellent. Now let's go ahead and do the graphing. I've already got one of them graphed for you. Here's the pre-image, or the polygon matrix that we set. And here then is the image matrix. Let me label those. Well, I kind of already have, haven't I? Because I said W prime, X prime, Y prime, Z prime. Okay. Now, notice what I've done here whenever I graphed the polygon matrix. For point W, I had to look in its column to see that it had the coordinates -3 and 6, and then I went to -3, 6. That's how I graphed W. Then -1, 0 were the coordinates for point X. You can see that's -1, 0, and so forth. So now let's go ahead and do the same thing with the image matrix here. We're going to graph the points -5, 7, -3, 1, and so on. So there are the vertices for the image, and here are the sides for the image. Voila, we've got ourselves a translation, and we use matrices in order to make it happen. Alright, so at this point you ought to understand how to represent a polygon's vertices with a matrix, and how to translate a figure using matrices. Appreciate you watching, guys. Later.